Today, we will solve logarithmic equations. Yesterday, we were working on solving exponential equations. So we have a couple of strategies for solving log equations. The first strategy is that we must isolate the log if it's only on one side of our equation, and then we change the log equation to exponential form. The second strategy involves having more than one log in the equation. When that happens, we must condense and then solve our equation. In the first example, we see log equals log. We have solved problems like this before by using the one-to-one property. We can just equate the x plus 6 to the 4 minus x and then solve the equation for the variable. X equals -1, and so we will do a check. And in doing the check, we see that the solution is x equals -1. Again, this problem uses the one-to-one property, and it is a review for us. Now, here we see that we only have log on one side of the equal sign. So what we want to do is isolate the log by dividing by 2 on both sides. Then we're going to put the equation into exponential form. And now we're just going to solve for x by dividing both sides by 3. And of course, we always want to do a check. Here is another example. We see log only on one side of the equal sign, but we want to isolate the log by adding 5 on both sides. Now the log is isolated, we can write our equation in exponential form. Now that it is in exponential form, we can simplify the 10 to the second power and then solve our equation for x. And x is 20, and of course we definitely want to do a check. In this example, we have a natural log, but log is still only on one side of the equation. So what we want to do is isolate the natural log by subtracting 5 from both sides and then dividing both sides by 2. And that gives us the natural log equals -1/2. Now, in a natural log, we need to remember that the base is e. So if the base is e, we can write our log equation in exponential form, and we will get x equals e to the -1/2 power. Now we can use a calculator to simplify this expression, and x is approximately 0.607, and of course we want to do a check. All right, in this example, we see that we have log plus log equals a number, and when we have two logs on the same side of the equation, we have to use our condensing properties. So in this problem, we need to use the quotient property to condense because we are subtracting two logs. And when we use the quotient property, this is what we arrive at. Log base 4 of x over x minus 1 equals 1/2. Now that we've used the condensing property, we can now rewrite our equation in exponential form, and we get 4 to the 1/2 equals x over x minus 1. Now, we know that 4 to the 1/2 can simplify to 2. Now we're going to solve for x by cross-multiplying and then solving our equation for x. And we see that x equals 2. And of course, we definitely want to do a check. Now, as always, if you have any questions, please write them down and we will talk about them in class during our next session.